Hey guys, welcome back to another video in Proof Faculty. Today we're going to be exploring integration, and yeah, if you can follow today's video, then there isn't a single high school integral that can phase you, basically. So let's get started. So the first type of integral we're going to start with is integration by substitution, and in the name you're going to have to find a valid substitution to plug into your integral to make it a lot easier for you to integrate. So with this kind of integral, we're going to have to set a substitution u equals, let's take the function here, 3x squared minus 1. And when it comes down to integration by substitution, you're going to have to differentiate your substitution. So du essentially will equal the derivative of this. So 6x dx. And what I want you to do is here, write it in terms of dx so you can plug it into your original integral. So dx would just equal to 1 over 6x du. And when you take dx and plug it in here again, this is what you get. Your integral now becomes x 3x squared minus 1 to the power of 4 du. And essentially what you get here is these two cancel out, so you're going to have 1 over 6 factor outside the integral, so it'll look something like this. Right? And now you could just take your u value here, the substitution, and plug it inside here. So now your final integral just becomes this. 1 over 6 u, because you plug that in, all raised to the power of 4 du. And now your integrals become very, very simple. You could just integrate this simply, 1 over 5 plus c. And now your integral is just 1 over 30 u to the 5 plus c. But remember, this is not your final answer because you've put in a substitution. Your original question wants it back in terms of x. So what you essentially have to do is just plug this back in here and you're done. So it'll just equal to 1 over 30. Plug in your u, which is 3x squared minus 1, all raised to the power of 5 plus c. Please do not forget your plus c. If you do not add your plus c, your integral is basically wrong. No matter what you do, it's just wrong. Okay, so now that we've done integration by substitution, we can move on. It's pretty simple. There isn't really much to it, but you just have to recognize and find a suitable substitution. That's probably like the hardest part when it comes to integration by substitution, finding a suitable substitution. Now let's move on to integration by parts. The name may sound a bit threatening, but at the end of the day, I feel like it's also pretty simple, but there's a bit more rules to remember when it comes down to integration by parts, but nevertheless, I'm sure you guys can do it easily. Anyways, so when it comes down to integration by parts, you only integrate by parts when you have two terms that multiply by each other. So in this case, you've got an x term multiplied by a cos x term. You've got an algebraic term multiplied by a trig term. So integration by parts only works when you're multiplying two terms of different types. And in this case, as I said, algebraic term and a trig term. Keep in mind, it will not work when they're the same term. So if you have like two trig functions multiplied by each other, integration by parts will not work. So essentially in integration by parts, you've got to remember this expression, this acronym. If you remember this expression, it'll make life so much easier for you. So the L stands for log, the I stands for inverse trig. You won't really come up with much inverse trig in high school, but it's good to remember. A is for algebraic terms, T is for trig, and E is for exponential functions. And in this term, we've got an algebraic term and a trig term. The algebraic term here comes before the trig term. So now we know we could set our u value as the algebraic term because it comes before the t. Whichever one pops up the first is what you're going to set your u value as. So u equals x, and v prime equals cos x. If you get this down, the integration by parts just becomes so much easier. Remember this, please, please, please remember this. Anyways, if you find the derivative of u, it'll just be 1. And the integral of v prime would just be sine x. And the formula for integration by parts is just uv, these two multiplied by each other, minus the integral of u prime v dx, these two multiplied by each other. So if you plug the values into this equation, this is what you get. X sine x minus the integral of sine x dx. So essentially what you basically said, the integral of this is equal to all of this. And the integral of sine x, easy, you guys could do it, is just x sine x minus cos x, because minus cos x derives to sine x. And keep in mind, you've got a minus outside this integral, so it'll just be plus cos x plus c. Remember your c. So the only really difficult part about integration by parts is, I guess, like messing up with your signs, but please be very, very wary of this minus outside here, because when you're differentiating trig functions, it's very easy to get negative values, which will screw you over if you don't take into account this minus. If you really don't want to use the integral by parts method, you could use the DI method that I've come across from Black Pen, Red Pen. Check them out, my favorite maths channel. But anyways, it works as so. You set your D and I. D stands for differentiate, and I stands for integrate. And similarly, using this acronym here, you're going to have to set your u value x under the d value, differentiate side, and your cos x just comes here. And what you gotta do with the DI method is just differentiate until you reach 0. So x differentiates to 1, 1 differentiates to 0. The integral of cos x is just sine x, and the integral of sine x is just minus cos x. And with the DI method, you also gotta remember, you gotta throw a plus behind the x here, minus behind the 1, plus behind the 0. This scheme keeps going on forever. So just remember, it starts with a plus and it goes to a minus, then plus, then minus, etc. And all you've got to do now is just cross multiply, and your final integral would just be x sine x minus minus, so that's just plus cos x plus c. You get the same answer. You let me know what method you like, but yeah, it's up to you. Guys, here's a nice question for you guys to try. I want you to pause the video right now and try doing this question. I'll be going through in a second, but if you could get this right, then there's no stopping you right now, except like probably uni level maths or whatever. But all right, let's think about this. You've got an ln x term inside your sine function, so this calls for a valid substitution term. So let's say u equals ln x. And we find du is equal to 1 over x dx. dx is just equal to x du. And if we plug this back in here, this is what we get. Sine u, because you plug in your u value in there, x du. And to isolate the x term and write it in terms of u, you've got to raise your power here, your ln x power to the power e to the power of ln x. So e to the power of ln x is just x, so e to the u is equal to x, and now your final integral is just e to the u sine u du. Now you may be thinking, oh, what do? I've got two terms multiplied by each other, got an exponential term and a trig term, integration by parts. So when it comes down to these two though, I do not recommend using the DI method, because you've got terms that never differentiate to 0. So this is like the main drawback of the DI method. If you've got two terms, none of them differentiate to 0, do not use the DI method, it will not work. You'll go through an endless loop of differentiation. So let's go do integration by parts now. Remember the expression, Liate. Exponential comes last, so I know I gotta set my let's say z value to sine u. So z equals sine u. And v prime equals e to the u. So the derivative of sine u is equal to cos u. And the integral of e to the u is just e to the u. The rate of change of an exponential function, depending on how, and not even depending on how many times, no matter how many times you differentiate, will always be the same. That's the beauties of an exponential graph. So anyways, remember the formula is just going to be zv minus the integral of z prime v du. So what you get here is e to the u sine u minus e to the u cos u du. You're going to integrate by parts again. It is very tiring, I guess, but you got to bear with it. So z is equal to cos u, v prime is e to the u, v equals e to the u, and the derivative of cos is just minus sine u. So now this integral is just equal to e to the u cos u minus minus, so it's just plus the integral of sine u multiplied by e to the u. So if you look closely enough, you're going to keep getting integrals over integrals over integrals. But the thing is, when you have something like that happening, you need to recognize a pattern that's going on. So if you remember, our final integral was this, and we've got the same integral here. So essentially we're trying to find this integral, but it pops up back again here. We've got to integrate by reduction. But the thing is, it's not as complicated as you think. So if you set this integral here as I, what we are finding, we could say our final integral would be I equals, this is what we found, e to the u sine u, minus the integral of this, which is all of this. So it's just minus e to the u cos u minus I. You drop in an I again. So with easy, simple substitution, you could find the integral. So you could move the I to the other side and say 2I is equal to e to the u sine u minus e to the u cos u. So it'll just be e to the u sine u minus cos u. Right? Factorize the e to the u, makes it a lot simpler. And so that I could fill my board. Yeah. So now I essentially equals to a half e to the u sine u minus cos u. So we found our integral again, but in terms of u, remember I told you in the substitution method, you're meant to have it all in terms of x or whatever the initial function or integral was given to you. So to get e to the u is just x, so your final integral which would be x over 2 sine u, which is just ln x, so sine ln x minus cos ln x, obviously plus c. Remember the plus c. Please remember the plus c. I made way too many mistakes forgetting the plus c. Anyways, besides the point. I hope this video helped, but if you have any questions about this, put it down in the comment section down below. But if you caught on and you understood this, I'm sure there's nothing that could phase you when it comes down to high school maths. And before you guys leave, I want you to try one last integral, and this time I'm not gonna help, so feel free to comment what you think the answer is. Yeah, just give me a sec. I want you guys to integrate this. Anyways, see you.